Kia ora koutou katoa, it's Mrs. Goodson here, and this video is about atoms and subatomic particles. It's the first video for Chemistry 2.4, which is about bonding and structure. Now, the learning objective for this video is to be able to explain the key differences between the three subatomic particles, electrons, protons, and neutrons. So first of all, thinking about all matter and all atoms. So all matter is made up of atoms, and matter can neither be created nor destroyed. Atoms of a particular element are alike. Atoms of different elements are different. And a chemical change or a chemical reaction involves the union or separation of individual atoms. As I said, elements consist of only one type of atom. Each element can be represented by a chemical symbol. So you would have come across these before. So we've got ones like sodium that's named after its Latin name, and ones like all of these ones are named after their Latin names. We've got like hydrogen, which is H, and helium, which has two letters. Always the first letter is a capital letter, and the lowercase letter is the second letter is a lowercase. So yeah, some of them are their letter names, like iron is named after ferrum, so it's Fe. Silver is Ag because it's named after its Latin name, and so on. So that's a list of ones that are named after their Latin names. So the atomic number for each element, which we find on the periodic table, gives us the number of protons. Okay, so for carbon, for example, the atomic number is 6. It comes 6 in the periodic table. So it has 6 protons in the nucleus. That's the middle part of the atom. And the periodic table is arranged in order of elements. So the bigger the atomic number, the heavier it is. And we start at 1 with hydrogen and just keep going after that. The mass number is the bigger number in the periodic table. So for carbon, for example, it's 12, is the total number of protons and neutrons together, because that's what's inside the nucleus in the middle of the atom. So for carbon 12, there's 6 protons and 6 neutrons. So you have a mass number of 12. So protons have a positive charge, and they are in the nucleus. Neutrons have no charge, and they are also in the nucleus, so they make up the nucleus together. So we've got protons and neutrons, and then we've got electrons. Now, electrons are really, really small, nearly 2,000 times smaller than protons and neutrons, and they've got a charge, a negative charge. Okay, so electrons have a negative charge, and they move outside the nucleus. So if you've got the periodic table and you've got the atomic number and the mass number, then you can work out how many protons, electrons, and neutrons are in the atom. So for example, we've got lithium. Lithium has an atomic number of 3. So it has 3 protons, and the atom will have 3 electrons because there's no overall charge. And the mass number is 7. So we've got 6.9. We just round that number on the periodic table. 7 for the mass number means that there are 3 protons plus 3 neutrons in the nucleus, adds up to 7. So that's how we work out the number of neutrons. For magnesium, it's got atomic number of 12. And so that means it's got 12 protons. The atom will have 12 electrons, and it's got a mass number of 24. We get that off the periodic table. And so the 12 protons plus 12 neutrons gives us a mass number of 24. Now, fluorine has got an atomic number of 9 protons, 9 electrons, a mass number of 19, so it'll have 10 neutrons. Carbon, another example here, as we said, 6. It's number 6 on the periodic table. That's the smaller number here. The bigger number is the mass number 12, so we've rounded it. 6 protons, 6 electrons, 6 neutrons. So as we said, the electrons are whizzing around the outside, but they're actually in energy shells. So we have 2 in the first energy shell, 8 in the second energy level or shell. So sometimes we call it energy level, and sometimes we call it energy shell. So we've got 2, then 8, then 8, and we're going to fill it from the inside, okay? 8 in the third shell, and then 8 plus in the fourth shell, okay? So these are the electron levels or energy levels. Now, the valence electrons are important because they're the ones that react in a chemical reaction. So we're really interested in the valence electrons, and they're involved in bonding. So that's going to affect the chemical and physical properties of the element or the compound. So how do we work out the number of valence electrons? So valence means outside shell. So we need to know how many electrons there are, then we just count out. So for example, let's look at oxygen here. Oxygen is number 8 on the periodic table, so it has 8 protons in the nucleus and it's got 8 electrons. So we're going to put 2 in the first shell. Can I draw 2? 2 in the first shell, and then I'm going to put, so that leaves me 6, so I'm going to put 6 in the second shell. So oxygen has 2 electrons in the first shell, 6 in the, so the outside one is the valence electrons 6, okay? It's also in group 16 in the periodic table, that's the column. Group 16, they all have 6 valence electrons. So this is another example, is beryllium. So all the atoms of beryllium are the same. They all have 4 protons and 4 electrons. So that electron configuration is going to be 2 and then 2. So beryllium has 2 valence electrons. It's quite a small atom. So how do I find the atomic structure? So if lithium, you look at the periodic table, you see it's got number 3, so it's got 3 protons. It's got a mass number of 7, so we've rounded this number 6.9 up to 7. It's got 4 neutrons, 3 electrons, and it's got an electron configuration of 2, 1. So we start with the nucleus. It's got 3 protons, 4 neutrons, 2 electrons in the first shell, and 1 electron in the second shell. That means it has 1 valence electron. So in summary, for this video, you need to be able to describe the key differences between the 3 subatomic particles. That means their charge, where they are in the nucleus, and their relative size. Also to be able to work out the number of subatomic particles, that's the protons, electrons, neutrons, from the data in the periodic table, that's the atomic number and the mass number, and then be able to write the electron configuration. Sometimes we call it the electron arrangement of an element, and identify the number of valence electrons or the outer electrons of an atom. So we're going to continue to learn about atoms and ions in the next video. Thanks.